In this video, I want to discuss solving equations and inequalities by factoring. All right, and I especially want to make sure to cover quadratic equations and quadratic inequalities. Now, to do this, what we need to remember is a simple fact of mathematics. Give me two numbers that multiply to 0. Not any other number but 0. Okay? I'll bet that no matter what you come up with, you can try as hard as you want, and one or both numbers is going to be 0. It has to. There is no way you're going to get out of this. Whatever you came up with, if the product is 0, then one of the numbers must be 0, right? Okay, so if you understand and accept that, you're going to be able to understand the trick we're going to use in order to solve equations with factoring. Okay, so suppose that we had something like this. Suppose we had x squared plus x minus 6 equals 0. All right, let's first factor it, which you should know how to do by now. Okay, now that we have it factored, we have a product, and the product must equal 0, right? So let's use the fun fact that we were just talking about a second ago. We said that if a product is 0, then one or both must be 0. So that means x plus 3 has to be 0. Otherwise, the x minus 2 must be 0. Okay? And so having gotten that far, you've got your two solutions. And yes, you can have more than one solution in algebra. All right? So that's how you solve equations with factoring. And if it was a more complicated quadratic, it might be more difficult to factor the dumb thing. But at the end of the day, it'll be the same idea. You have a product that equals 0, so one or both pieces have to be 0. Okay? And all the equations that you're going to solve by factoring are going to use the same basic idea. All right, now let me finish by talking about solving inequalities. Okay, so suppose that we modified this problem slightly. Suppose that instead of having a quadratic that was equal to 0, suppose we insisted that the quadratic was less than 0. Okay, now the same way that I had a fun fact for the product being 0, when the product was 0, I have a fun fact whenever I have a product, and we are going to factor it to get a product, when we have a product that is positive or negative. Okay, watch this. So if a product is negative, that's what being less than 0 means, right? If a product is negative, doesn't that mean that one or both factors doesn't that mean that they have a different sign? If one of them is positive, the other one has to be negative, right? If the first one is negative, the second factor has to be positive. They have to have a different sign, otherwise when you multiply them, you're going to get a positive. Okay? We're going to take advantage of that, of what the sign is of the product, to solve quadratic inequalities. So this would mean that either we have this case, either the first one is positive and the second one is negative. Okay, that's case 1. Okay, another case is x plus 3 is negative, but at the same time x minus 2 is positive. All right. So both of those are going to give us the two answers that we need. Maybe. If something weird happens in one of the cases, then we might have to throw out one of the cases. Let me make some more room, and then I'll be able to solve this. Usually it's a good idea to put the cases right next to each other. All right, and so maybe give them each their own column. So let's go ahead and do it. So the first one says x is bigger than minus 3 and x is less than 2 if I add 2 to both sides. Plus 2, minus 3, minus 3. Okay, so you can have something that's bigger than minus 3 and less than 2. Probably the most compact way to write it is that way. Okay, that's the first case. Now let's do the second case. X is less than minus 3, but also x is bigger than 2. Now let's be clear. It's and means something different than or. I'm not saying either the first inequality is true or the second. I'm saying they both have to be true. Let me ask you a question. Is it possible for a number to be less than minus 3 and to be bigger than 2? Of course not. All right. So you'll see that this happens sometimes. Sometimes you'll have to just throw out one of the cases as being impossible. Okay. So therefore, the first case gave the only inequality answer. Okay. Now, if you had, let's say that they both gave you an inequality, well, in that case, you'd have to combine them both, and that would be the answer. It would either be the first inequality or the second inequality. Okay. Let's do another example, and then we'll close. What about x squared? Oh, let's see. How about plus 13x plus 12 is greater than or equal to 0. Okay, so again, we factor it first. And this time we ask ourselves, first of all, this one, it could be 0, can't it? Okay, we already solved the situation where it was equal to 0, so now we're going to have 3 cases. We're going to have, let's have 3 columns. All right, so the first case is maybe the product is 0. If the product is 0, that means one or both are 0 of the factors. Okay, that's the one we know and love, where we're solving equations. All right, what if it's bigger than 0? Well, then both factors have to be the same sign. That means that they both have to be positive or they both have to be negative. Okay, so there you have it. Now let's go ahead and solve all of this, and then somehow we're going to have to put it all together. So the first case, subtract 1, subtract 12, subtract 1 from both sides. Just for fun, I'll just start each column. I don't know why I'm doing this, but probably not a good idea now that I think about it. So we get x is equal to minus 12 or x is equal to minus 1. Okay, so there's the 2 solutions of the first. The middle column, x is bigger than minus 12 and x is bigger than minus 1. Okay, just put that aside for a minute. That's valid. And then the last case, x is less than minus 12 and x is less than minus 1. So this time we didn't get any garbage. So all 3 of them have to be dealt with. Okay, before we combine all 3, it turns out you can clean up the second and the third one. Watch this. Okay, so the third one is making 2 requests. Would you please pick a number that's bigger than minus 12, but would you also pick a number that's bigger than minus 1? Right? Now, would you agree that if I pick a number that's bigger than just all I have to do is pick a number bigger than minus 1 and I satisfy both conditions? Okay, so one of the conditions is redundant, is unnecessary. All right, can you see which condition is unnecessary on the third column? Okay, If I'm less than minus 12, I'm already less than minus 1. So that one is unnecessary. Okay, so I either have to be the two purple inequalities or I have to be one of the solutions on the first column. All right, so I would say the solution this way. X is bigger than minus 1, or x is less than minus 12, or x is equal to minus 12, or x is equal to minus 1. Okay? Now, I know what you might be thinking. You might be thinking that's pretty complicated. You might be thinking, how do I know that that's correct? And that's a great question. If you're not sure if it's correct, remember what I said. Remember that wonderful freedom you have to check your answer by plugging in values. Okay? So you can look at the x has to be bigger than minus 1, or that's not, it doesn't have to be, but that's one possibility. Well, how about 0? Isn't 0 bigger than minus 1? Plug in 0 in the original inequality and you'll get 12 is greater than or equal to 0. That checks out. All right. Now, the second condition says x is less than minus 12. All right. Think about if x was equal to negative a million. Okay. If you plugged in negative a million, then the squared term would be huge, and so it's going to be bigger. So the whole quadratic is going to end up being positive. So that's going to be satisfied. And then you could also plug in the two numbers and you'll see that the minus 12 and the minus 1, and you'll see that those work. All right.